So hello, everybody that is online that joined the class. Thank you for joining on time. I'm sure a few more folks might trickle in as we get going, but it's time to get going. If you're watching on the videos, also thanks for staying up on it. I understand that this is a lot and it's going fast, so keep practicing. That is the key. We are on week 5 out of 6, so we are almost at the end, and we are going to be doing our back end design and development this week. This is by far my favorite part of it. This is going to be the core stuff that adds the functionality to our application. And we're in day 9. We're going to cover introduction to databases and CRUD operations. I've mentioned CRUD operations a couple of times in the past. We're going to dig into them a lot more today and start writing them at the end of today. And we're going to spend all of next session on Thursday and then probably part of Tuesday finishing up these operations. So we'll be very, very, very intimately familiar with these by the end. We got a lot to cover today. I want to make sure we cover all the theoretical stuff. This is kind of tricky in places. So I'm going to make sure that we're hammering the why we want to do any of these things, answer lots of questions if we have them. But I'm going to kind of skip the general if people have questions up to now. If you're stuck somewhere, reach out to me and we'll sit down and figure out what's going on. I'll do a quick review of where we are up to now. We're going to build off of what we have already. So if you've built up through day 8, you should be where we are. But we're going to start with our kind of high level talk about databases and some of the design that goes into them before we dive into the actual coding. And we'll talk a little bit about CRUD again as a concept. We're not going to go deep into design, but databases in general are places to store data. So let's talk a quick second about how we've talked about data so far. This is going to be our third way of talking about it. When we first started, we talked about data in the sense of being binary and computers storing bits, the ones and zeros, in 8-bit chunks called bytes, right? So this is one sense of data that we started talking about. And we said all things are processed as data, binary data by the computer. Then the second time we started talking about data, it was in the programming sense of data types. And we talked about Python specifically, but this applies to all languages. They all use data types. Most of them are similar to the ones Python uses. But things like the literal strings, integers, floats, the Booleans, the trues and false, and then things that are collections like variables that can hold all those literals, and then lists, tuples, sets, and dictionaries that can hold other things. Things that have functionality, which is really just our functions, and then ways of grouping functionality in data, which was our classes that have attributes. And if you remember, that's the same as variables syntactically, but they're just bound to a class, like they're inside of a class. So attributes and variables look the same, but attributes are inside of classes. Similar to methods, methods and functions are basically the same syntactically, but methods are inside of classes, and that's the main difference. There are, some other differences most likely, but for our purposes, that's enough. So this is the second way we talked about data, right? The first way was binary. Second way was these data types. So that's the sort of focus review that we're going to go through for the concepts. Now today we're going to talk about data as it pertains to any database. So that data is any information that's stored like in an application according to a schema or a map, a plan of how that data is supposed to look. This information is always pertaining to some sort of real life object, usually a business purpose thing like customer data or product data. This could be streaming data of all varieties, but it's basically information about something that you want to write down and keep. This is what we mean when we're talking about data in a database, right? So we're not talking about binary, even though that's relevant because we know that it does break down and store as binary in memory and in storage, right? So that's still relevant to us. We're not talking about data types in Python, even though that's relevant to us. We're going to be using it and writing it. We mean the whole thing. So this could be house listings in a real estate agent's thing. So it's going to have address and all that sort of stuff. That's data in the sense that we're talking about. Now, there are all kinds of database types. There are the ones that we're going to use and have been using. Technically, it's already tied to the Django instances that we have. And they're called relational databases. And they're based on the structured query language, or SQL, or SQL. So what we have built into Django is called SQLite 3. And it's you'll see it in your list of files. If you look in the files, it's usually hidden. So it might start with a dot, but Regardless, the idea with this is that it's a structure as opposed to non SQL databases. So SQL is very widely used in a lot of organizations all over the place. It's very common. You'll see it everywhere, but it's not the only way of doing it, right? So not NoSQL or databases that don't use SQL include things like object oriented or document, things like key value databases, which are similar to what we saw with the Python dictionaries that are key value pairs, but an entire database of it. They can be hierarchical, they can be network. None of these types of databases use SQL, but I want to be clear. This is kind of a false dichotomy between relational and NoSQL. This is just to show that there are ways of grouping them, and all relational databases, even though there are several varieties of them, will all use SQL. And then all these other ones just don't. They're not really related to each other. Like object oriented isn't, very related to hierarchical or network specifically, except in the fact that they don't use SQL, right? So is this broadly making sense so far? Any questions about what we're talking about thus far?
Now, it seems to me the non-SQL type databases would consume different resources. Like that would be something kept in memory. So it would probably be very fast, but it would also only scale until you start running out of memory.
No, not necessarily. So the big difference kind of broadly with all this is that these are going to be good for data that is unstructured. So really big sets of unstructured data. And this is definitely not stuff for in memory. This is talking about the actual storage of in the data. These are all databases. So this is definitely storage, not memory that we're talking about. And so very large applications use, so like Netflix use things like this and Google and stuff, NoSQL. So really huge amounts of unstructured data can be handled really well in a NoSQL database. But again, we're going to
Just
walk
seems like
through.
there would be some lag time because if you have an object-oriented thing, I would think you would have to actually load your entire object out of storage into memory so that you could work with it.
Oh, okay. So then you're talking
So
about
I
how
mean,
you retrieve it,
you're
right? Yeah,
automatically
right.
you're adding a certain amount of latency just to accomplish that task. And the bigger that object is, the longer it
That's
takes to even access something from it.
that's
Just
getting a big assumption based on like again how you access things through SQL. So that's and again a little out of scope of what we're going to talk about here. We are going to talk about how things are accessed through SQL. Um, the reason I'm even highlighting this is just to show that there are tons of ways to do it. And to your point, Chris, is that it really depends on what sort of data you're even dealing with, and in the first place, and what you intend to do with that data once you have it in your database, right? So how you're going to expect to, like you said, retrieve it, do anything with it. The way you answer that question and how you're going to do that is going to depend on what sorts of questions you're trying to answer with the data and what you're trying to do with your application. So again, it may be worth your time to take unstructured data, structure it, and use it in SQL. It may not be worth it. It may be better to leave it in one of these other NoSQL ways of doing it and stack it up that way. It might be faster that way. So again, there is no like clear advantage on these things. It really depends on what you're trying to do and what the data set is that you're dealing with. Does that make sense?
yeah. I mean, I've worked with a document version of that. It's just JSON, right? Where
Yes.
everything gets stored in a very XML type looking
Yeah. So
structure, curly brackets and names of
yeah, but I'd be careful.
subsets of
Don't
data and embedded things. Yeah.
just real quick. Don't confuse XML and JSON. There's two totally different things. So
Okay. Yeah. Yeah.
JSON looks a lot like dictionaries and is key value pairs, but in document style NoSQL, it'll be very similar to the file structures that we've been talking about in Linux, where there's a directory that holds a file, and that file or document is in the terms of the thing, but it's a file, and then that file is like the object, the thing in the database that exists, and then it expects to see JSON that you were talking about. So it's that JavaScript object notation, which looks like a Python dictionary, it's curly brackets, and there's key value pairs. That'll be inside the document explaining what's in there. So if it's like, say again, real estate or something like that, the document will be the house, and then inside it'll have all the details about the house. And what's cool about that is it doesn't have to be consistent from one document to the next, right? So you have two documents in there that are both houses, and one has the address and the coordinates and all this other stuff, and the next one just has the address. That won't break anything. Whereas if you're missing information in a relational database, you have to handle that blank space somewhere because it's like a solid grid. So again, it's really dependent on what you're trying to do with the data. What kind of data you've got is going to be the sort of reason you make the decision here on what kind of database you're going to use. A lot of times things are just going to default to start like we did with this with Django. It starts with SQL. So this is really the starting point a lot of times. And it's probably where you're going to be most of the time, especially getting going. Any other questions? Thoughts about this before we move on? And this will all become a lot more clear as we get through SQL a little bit deeper here in a second. We're not going to get too deep, but we're going to get a little bit into it. Excuse me. All right, cool. All right. So relational databases specifically are broken down into tables. That's one of the really important concepts inside of a database. So the database itself is one object, one thing that you make, and then you make tables within that database. And we're going to make tables today in the terms of Django and Python. They're going to be written in classes. They're going to be defined as classes, and we'll do that for our task model. We'll set up the table for tasks. But tables consist of rows that go across, right? So left to right. And each row contains one record and one record only. And they are uniquely identified with some sort of primary key, something that says that that row is unique. There's kind of a key concept, pun very much intended, with relational databases. It's very important. It doesn't have to always be there, but there is some sort of unique identifier. Primary keys are very, very common. We'll see some usages of them soon. It's one of the key traits, I guess, of a relational database. All right, so tables with rows, and the other piece is columns. So it's broken down to rows and columns. So a row will be one record. The columns say what data is in each part of that record. So you can picture in some ways a spreadsheet, but it is not a spreadsheet. So I want you to so kind of challenge that in your mind to decouple this idea of databases and spreadsheets being the same. They do somewhat look similar in the sense of having rows and columns, right? Spreadsheets also have rows and columns. So you can kind of picture it that way. But for what I'm going to show you next, it's going to look very differently when you actually make your database. One of the big differences in the way things are handled in spreadsheets and databases and the way people use them is something called normalizing. Databases are what's called normalized. So I'm going to go through this really quick. We're going to go through this concept of normalizing a database. We're going to go from a somewhat unstructured database, not exactly unstructured, but unnormalized. And it would be something that you might find in a spreadsheet. And we'll kind of walk through converting that into a database and see why we would want to do that. So I'm going to step out of this real quick. I'm going to use this example that's just on a Wikipedia page. This is a great page. I'll share the slides out. I totally encourage everyone to look for it and have a look. It's written by some other taught person. So I was going to make my own example. I realized this is already very well done with an example of step-by-step normalization. So we're just going to go through this one instead of me reinventing the wheel. But again, take all this stuff with somewhat of a grain of salt, looking a little bit further. There's a fairly good description, high level, of why you would want to normalize, what sorts of things you're avoiding, things like this insertion anomaly. It's like what goes wrong when you insert something, updates. And again, we're not going to go through all these details of what might go wrong. This is useful to know. But as you scroll down, it'll have these things called normal forms. Now, this is what we refer to when we're trying to normalize, is we're trying to get it into a normal form of some sort. So there's a first through, looks like sixth normal form, and then there's several other labels that go into it. And this is a very deep topic. I promise you we're not going to step through all of this, but I do want to show you a little bit of it to get the concept of what's happening. And this is part of the design of databases, particularly relational databases. So this explains what the constraints are. Here's just the top one, the unique rows. There are no duplicates, right? So that's part of the first, normal form situation. And then there's a whole lot more. We're going to skip down through this and go straight to the examples of step-by-step normalization on this page. So this is taking what's called initial data, and it shows it right here in this kind of spreadsheet looking thing, because this is a good example. Let's think of this as a real life scenario where you're a developer and you come into a bookstore or a book retailer online or something like that, and they have to track things like books. So they have titles and all this information that's across here, and they've been doing it in a spreadsheet. So this is their spreadsheet, and this is what's called unnormalized, right? So it's not unstructured. There's some kind of structure to this, but it's a spreadsheet and we want to put it in a database so we can run it as an application and not in the spreadsheet. So we're going to step through these steps, just a couple of them, and we're going to go from this unnormalized data, where this here again, where we have title, author, and then the first thing we're going to do is we're going to look at this subject, and it has a table inside of a table, right? So it's got this MySQL database design under the subject thing. So that we can't have. We can't have tables within tables. What we need to do is separate this subject into another table. So down here, we've broken down the book table by itself. We've taken out the subject as it was and added it down here in what's called a linking table between the title and the subject. So now we can look things up by the title and it'll say which subject is returned. So this is one way of normalizing. I'm not saying that this is the best way of getting first normalization. This is one step. This is what they offer here. The key takeaway here is the breaking down of a wide initial set of data that had a whole bunch of columns, looking for columns you could take out of that and put into a separate table. That's really kind of the recurring theme throughout all these normalizing steps, is that you're trying to get this separated so it can be looked up easier and faster by one specific thing. So let's go to another example real quick of second normalized form. So this is second normal form. Similar data set where we have something separated by title. It looks like there's two rows with title that are only different because of the format. We have hardcover and ebook, and the price is different based on that format, if it's hardcover and ebook. Other than that, all the rest of the information, these columns between the first and second rows are the same, and between the third and fourth rows, if you look, it's just ebook, paperback, and the price, right? So very similar to what we did before. Instead of leaving this how it is in this, what we would assume would be like a spreadsheet sort of thing, we're going to break this down into books. So each row has one book in it. So the title, and again, it would be even better if we had a key to put this on, like an ID, a unique ID or something like that, a primary key. But we can use title, that's fine. And then down here on the price table, we have the prices because those are going to be unique. These are going to be absolutely different. There's going to be this combination of things. This title, format, and price is going to be a unique combination of three things. And so now we've got our hardcover version of this title and its price, and we have the ebook version.
If I just renting them from Amazon, they always way cheap.
And that is a way of getting second normalized form. And again, it's not as important that we do the example exactly like this and say that this is a perfect way to get normalized, second normalized. I really want you to see the idea of creating multiple tables that are narrower, have less columns than the larger original data set had. That's kind of what happens at each one of these steps. But each one has a different goal of what problem it's solving and why you would do it. So without getting too deep into any of these, it's going to show that recurring theme that we start with kind of a broad, this one has book, but this also breaks down the, what was it? Genre or ethnicity, I think we're looking for, nationality, the author's nationality. So now we have a price table, we have an author table that includes the nationality, we have publisher, we have genre. And you see these are several tables that are only like 2 columns wide. And the widest of all of them is now only like 5 or 6. So that's really what's happening here, is that we're breaking these things out into their own tables that are separate and have less columns of information, basically. But we're linking them together still in some sort of relationship. So as I go through these, I scroll down through these normal forms, you see the pattern sort of repeats. There's linked tables between suppliers and franchises and books. You see there's multiple tables, but they're showing the relation between these things so that they can be found, so they can be accessed, so they can be looked up. Is this generally making sense? Has anybody got any questions so far about what is arguably a very confusing and deep topic of database normalization? I'm going to keep going through examples of why we would do this, but is anybody got a burning question conceptually they wanted to ask before we move on?
So if you want to look up a particular, let's say you want books for less than $20, right?
Yep.
You would be creating a table like the ones you see with price as the major the major sort, right?
Michael, I swear, every time I ask for questions, you ask a question that I'm just about to cover. It's great. You're leading
Okay.
into like the very next thing I'm going to cover. So
I'll just
to answer your
listen along.
question, yeah, to answer that's great. That's a well-timed question. It's a good question. So what I'm going to do is show again. That's exactly where I wanted you to be. It's like you kind of get what we've done to here, and I'm going to keep showing you the why we would do this, and that will answer your question hopefully. So if I haven't answered your question after the next like 2 slides, which should be about the end, I got like maybe 3 more slides, then ask a question again. But I think I'll be able to answer it. So
Okay.
let's slide back over to that, and we'll press on with that. So that's all I want to show you with normalizations, but generally just get a sense of what the process is. Now I'm going to try to show you a little bit about why we would do this. All right. So we've talked about breaking the data from some sort of unnormalized form and breaking it out into separate tables. Now, the reason you would do that is because you want to match it up to whatever your database schema is, or the map and design of how those database tables will relate to each other and what you're going to do with them. So what I have on this slide is an example of a very common and arguably one of the simpler database schemas that's out there. There are tons and tons and tons of them. This isn't by no way like the best or the only one or anything like that, but you'll see it a lot. This is called a star schema. It has a central fact table and is surrounded by dimension tables. Now, the idea here is that what we're tracking is sales. The middle table in blue is our fact table. So it's fact underscore sales. And if you look, it has date ID at the very top. And then if you follow that weird little kind of dots in the little line that goes up, there's a key up here on the dimension underscore date table that links to the ID. So that's the key, the primary key of that date. The date's got all these different fields like the day, day of the week, month, and all that sort of stuff. But the fact table just stores the ID. That's it. Similarly with store ID and product ID, those link out through primary keys to this dimension underscore store and dimension underscore product tables, respectively. The only unique field in the fact table in the center is the unit sold. So that's the only thing that doesn't link to something else. All 3 of the other fields in this table link to another table. Now, the purpose of this is if imagine a sales team, the reps want to find out how many units have been sold in a particular time frame, or a regional manager or something like that wants to figure out how many units have been sold, how many products, a particular product, which store sold more or something like that. You would want to go to this fact sales table would have that information for you. And all you'd have to do is filter by the date IDs that you wanted to do. And again, the purpose of this schema that you would set up and design ahead of time is with that in mind. Whatever it is you're going to want to do with the data, you're going to build your schema according to that. And then you're going to take what the data actually is and normalize it into that schema. Does it make sense so far? Michael, would that kind of start answering your question?
That's perfect.
Cool.
So in the fact sales, you can conceivably use any one of those datum in there, right?
Yeah, to look it up, you mean?
Yeah, and then you could
Yeah, absolutely. So let's say you want to look by a particular date, then if you had the date ID, like whatever the date ID is, then you find that date ID. Let's say you want to find everything since date broken down over here on the table is day of the week. So you want to see all your sales on Tuesdays. Then you find the date ID that has Tuesday, drop that in there, and they'll give you all your sales. It'll show you stores, products, and all that kind of stuff as well. And you can start doing all the data analysis that you want to do based on this schema. And again, then the key is knowing where everything is and how it's broken out.
Yeah. This is pretty much the way SQL works.
This is SQL. Yeah, this is exactly. So we're going to get to SQL next, right? So this is the structured database that we do. So this normalized and it's structured this way. The relational database, again, that shows the relationship between these tables is the key that we're talking about. We have a set of tables and we show how they're related to each other, right? So the fact table is related on the date, store ID of product to those dimension tables. Cool. Now, to your point, Michael, the way you would access this is through a structured query language, or SQL. So the way you do this is the reason this exists is to access data in a database and then do things to it. So we showed that star schema before. That's like a map of what the tables are going to be. What you do with SQL is now do things with the data that's in that map. So it'll go and look things up, pull it together, changes, all those things that you can do with information, add stuff to the database and whatnot, but it'll traverse that schema and find the things you need using SQL. So it's the language that you use generally to answer some kind of question. So for example, using a somewhat similar structure that we just looked at, imagine we had a question that said, how many TVs of each brand were sold in 1997 in each country? Let's say you're doing some research from a really long time ago. Again, we don't ask these kinds of questions as developers. I don't really care what your question is, or as data engineers, we don't really care. Data scientists either. I mean, we do kind of care, but that's your problem with your question. So we just want to figure out how to answer it. So an example of a SQL query, and we're not going to write SQL queries, but I want to show these to understand what it is that's going on when we write our queries in Django that access the database, because ultimately it boils down to SQL, since we're using a direct relational database. It is at some point becoming SQL, right? So the way we would do this is right here. So this is an example of a SQL query is what it's called. So this is what is sent to the database. Now we're not going to go through all of this, but I do want to highlight 3 important pieces and make sure that we remember those pieces, because really all you need to know about SQL to be able to move on and be able to use it through a framework, or if you want to start learning it more and dive deeper into it, this is a really good starting place. So this is the entire way that we would answer this question, how many TVs of each brand. Without going through each line, the most important parts here are the select statement at the top, which says what we want to get out of our database. So specifically what we're trying to get is in select. So we select what, and then from is which table we want to get it from. So we already know which database we're in by the time we send the SQL statements, right? So we just need to specify the table that we want to get the thing that we said from select, which table. So select what from which table, and then where is the filter criteria. So we say select what from which table where the data meets these criteria. And those are the 3 most important pieces of an SQL statement. There's a lot more that goes on. As you can see in the from statement, there's all these inner joins and stuff like that. And, you know, you can do a lot of fancy stuff with it. It's really cool. This is going to end up being a lot of, you know, discrete mathematics, and sets really help you out with this sort of thing. We're not going to get into this. We're not going to write our own SQL statements. It's worth learning. But the main parts for us to remember while we're doing our web development and we're writing our backend stuff and we're interacting with database, even though we're going to do it through Django, which means we're going to write it in Python, it is at some point going to be breaking down to SQL. We're not going to see the SQL, but it's going to be doing these things. It's going to be doing the selecting what we want from the table we want, where it meets the criteria that we send it. All right. Any questions about that? All right. Cool. So that is all we're going to talk about database, you know, design and whatnot. We're going to get a little hands-on making our own database here in a second. And then we'll move on to our CRUD operations. I've definitely mentioned these before, but we're going to talk more in depth about them and then spend a lot of time getting intimate with them today, Thursday, a little bit of Tuesday, next week. And so this is an acronym that's basically all the operations that can be done in a database. And I put using SQL, but that's not exactly, it's a little bit misleading. You will use things like, it will, like I said, boil down to SQL and a relational database, but CRUD operations are not specific to SQL databases. This is what all interfaces do regardless of what your database is. So this is creating records in the database, creating the rows in a relational database sense, or creating documents if it's a document database, or, you know, objects if it's object oriented, reading those those records, updating them or deleting them. So this is CRUD. Create, read, update, delete. This is what backend development is really about. You're going to be making these functions in the web application, right? So to do that, we have to have a database first to interact with. We have to define our tables inside to do that SQL type statement. Remember, we have to have the elements of our SQL statement that would say select what from which table where this certain criteria is met. So we have to do all those things, but we're not going to do directly in SQL. We're going to be writing our CRUD operations in Python using Django. Any questions about this conceptually before we dive into our hands-on section? Nope. Right. Great. So let's do that. So again, what we are doing as an example app as a to-do list because it exemplifies all of those CRUD operations quite well without getting too complicated. So we're going to set up our database today. As a first step, we're going to define our task table. We're going to do all the steps that you go through to make a database table in Django. And then we're going to start getting into our first CRUD operation, which is going to be read. We're going to view something before we do any of the creating and updating. Those are going to be a little bit more complex. We'll save those for Thursday. So I've gone over to Python Anywhere if you're following along. Again, treat this kind of like an exercise video. Try to stay up with me on this. This is like the fast, intense version. I sent out the documentation earlier. You can copy and paste those things over and just create the files in the directories. That's like the lower impact version, and that's totally fine. There's nothing wrong with doing it that way. The full example files should be in there in the documentation at the bottom in the references. The full thing is in there. So even if you don't want to follow step by step, just make the files in the right directories, copy and paste it over. The key is that you get these things running and understand the concepts that are going on. So if hands-on for you is just copying and pasting, that's totally, totally fine. Try to write it from scratch if you can, but that is also acceptable. So I'm going to a console. And to get in the habit or stay in the habit and develop the habit, we're going to just start off in our home directory. So we got UTC time, tilde, $. And the first step we're always going to do is start our virtual environment. If I can spell things. All right, so we do venv/bin, and I'm using tab complete again. So I type the first letter, hit tab to make sure I'm in the right place. If it doesn't fill in the way I expect it to, I know something went wrong. And then we got the virtual environment started. So now we're going to go into our top level project directory. And just so we know where we are, let's do our favorite tree command. Get rid of our JavaScript folders. Lost control, CSS folders and image folders. Cool. All right, so quick reminder, this is our top level, the dot. We're going to be referencing that a few times today to make sure we remember. So here's our database again, SQLite 3 that I told you comes with it. So we're not going to open that file and do anything with it, but we'll be creating our what's called models and migrating them into this file, and that's where they're going to go. So there's our manage.py file. That's where we're supposed to be at the top. We're going to be doing a lot of work today in the to-do directory, specifically in our models.py. So that's really where we need to be at first. We're going to be making a few other directories and files as we go, but let's get started there by defining our first what's called model. So now that we're in our right place, so we come back here and run any things we need to, I'm going to open up files in a new window and navigate there. So we're using the little bit more friendly GUI to do any edits to the file itself. So again, I'm going down to the to-do directory and I'm going to do the models.py file. I'm going to open that up. All right, so once again, I'm in my site to do models.py, and we are going to define our first class or model in Django's terms, right? So it's just going to be a Python class, the way we've done before, just the word class, lowercase. And then we're going to call this task, singular, capitalized. And we've imported, you see at the top, it comes default imported on line 1 with this django.db import models. So we could use that, and we will, because it's got some great stuff built into it. So why not? So putting this inside the class means to inherit from that model specifically. So take stuff from the models.model, and we're going to now customize that and do some things with it, right? So this is how you start most database models in Django. There's other things you could do, but this is really the standard starting point is inherit the models. And then we're going to define some attributes. If you recall, those would be the look like variables. In database terms, since this is, again, think of this as the example of a database that we're defining here. This is going to be the row, or I'm sorry, these are going to be the columns. So these are going to be the column names that you want to have, right? So normally we would have designed this out thoroughly with the schemas and all that sort of thing. But since this is very simple, we're just going to have this one model and we just have a task in our to-do list. We're going to do a very, very simple task that's going to have title, due date, and a status that we could do. So we show doing a drop down. Now these things, you could have notes or uploads or, team members or signees. You could make a task very thorough, very, very big. I'll leave that to you to do later. We're just going to put those 3, think of them as columns, into this table, right? So task is the table. And now we're going to define our column. So the first column is going to be title. So we define that the way we do any attribute in a class. It's just lowercase title. And then we're going to do models. So we're going to reference that models again. And we're going to give it a built-in what's called character field. So capital CHAR and then capital FILD. And this is required to take a max underscore length keyword argument. And I'm going to set this to 100. But the idea here is that you can set this to whatever you expect the length of characters to put in that people are going to be entering when they put these things in. I think 100 characters is probably going to get done for a task title. But you could change all these things later. So you follow the same process that we're going for writing this. You can come back and adjust your database later if you need to make this larger. If you decide it's too much space, you want to make it smaller, you can do that too. But be careful, there's going to be different implications when you make changes in here. But again, for a character field, for this char field thing, max length is required. You have to put something in there. And it's a good idea to keep it kind of close to what you expect your input to be. If you do have a hard maximum that you want to expect, like if you want to put in 2 letters for the state or something like that, you can set that here. That's what this would be good for. All right, so there's a title. That's simple. That's it. So just anything that's basically text being put in can be put in that way. You can use a character field as we did. And now let's do something with a date. So let's do a due. This is going to be the due date that we're going to put in here. We could call it due date if we wanted to. Again, these are variable names, attributes like any other class. I'm just going to go due models dot date field, also all caps, and it doesn't take any arguments. So it's just, open and close parentheses. Now, if you're following the documentation, quick note, I did skip one thing. I'm going to go kind of back. This is more how I would write a model as I'm actually writing it. It's going to have all the same pieces as what's in the documentation. So if you're following along and you think I skipped something, I'm going to get that something here in a second. It goes kind of somewhat loops. Michael, you got a question?
Yeah, I do. When it says date field,
Yep.
both of the letters are capitalized, right? Is that?
Yep. That's intentional. That is exactly how it's supposed to be. The same thing with this character field. The first letter is capitalized after the period, and the second word.
Okay, yeah. So is that unique to just date related functions?
No, this is all you're going to see that is pretty much all these built-in fields for models. These are all the fields they're going to be capitalized like this. It's just the convention that Django uses in their fields. So staying for char fields, it's got nothing to do with it being a date. All the fields are going to do that. So like email field is going to be capital E, mail, capital field. That's just the pattern Django uses.
Okay. Is that because within models, it's a class object? Okay. Yep.
Probably, yeah, most likely, right. I mean, that's the thing, is it may not be that it's a class, but you have to read into exactly why they said that in the documentation. So you can look this models up and see exactly why they named it that and what it is exactly, right? It could be, referencing some other subordinate class. But these are the ways that you set them in there. I guess I don't have a really great answer for you on why they chose to do it capitalized.
I'm just curious if there's like date field dot, some other option that might be a method within a class that's part of the models.
Usually not. So that's the thing, is usually if you make any changes to it, it's in the actual call itself, like passed as arguments would be passed to a method normally.
Sure.
So my suspicion is that these are just methods like any other method, because they appear to be and they act like it in most cases. But that is a good question, because they're not, I guess, following the normal naming convention. We normally do lower, but those conventions aren't strict, right? There's nothing in Python that would break if you named your methods like this, right? So, good questions though. All right, so the last thing we want to get is we have our title, we have our due date. That's all we got to do for dates. This is going to be built in to give us our date stuff. We don't have to do anything with that because it's all built in, which is the beauty of the backend frameworks. And then the last one we're going to do is the status. This thing's going to have a status, and it's going to be a drop down. And the way we're going to do a drop down is we're going to have to give it basically the same thing that we had before with the character. Models. Let's do it right. Models dot character field, like we did before. So CHR FILD, just like we did with the title. So that's also going to require some sort of max length, right? All max length. And we don't need to have it as big as this one. Let's do 30 for now and kind of hold some spot here. Then we're gonna do some other things. So we're gonna do some choices need to be added in here to make it a drop down. We're gonna pass it a set of choices. So choices is the keyword. And what we're gonna do is we're gonna set it to this all cap statuses. And we're gonna make that up here in a second. We're gonna write what that is. There are a number of ways of setting choices. We could just write them in here as a tuple. I'm going to separate them out in another place just to show you that that's one way you can do it. And it's again sort of demonstrative of patterns that are helpful when things get larger. It doesn't make a ton of sense here with just two choices. We're only going to have to do incomplete. It's going to be kind of a hacked way of doing it to make it a little faster, but I just really want to demonstrate how these things can be set. We could set them directly here, but I'm going to make this list here in a second. Let's actually do that first. So let's close this up. So this is a well-formed status thing. We're going to say this thing is choices with statuses, but we haven't made statuses yet. So I'm going to copy that. And up here, up above the title, I'm going to define this statuses as a list of things. So this could be, it doesn't have to be a list. This could be a dictionary, but I'm going to use a list. And inside the list, we could have tuples, and that's what I'm going to use. So a tuple, if you recall, has the opening parentheses and close parentheses. So I'm going to open and close those now so I don't forget. And this is going to take a pair of things, both strings, and we're going to have our statuses in here. So our first status is complete. And I'm going to write it twice. Now this is, I'm going to call out, it's a little bit of a hack. I'm not going to try to pretend this is the best practice or anything like that. This is just going to make our front end template when we go to make it a lot simpler to call these things. This first part of the tuple is the part that's stored and actually assigned in the database. So this could be an integer or something else that could be unique and look up, and that would probably make more sense in a larger project. This second part is the human readable part that comes out, right? So there may be a reason to keep these different. This is somewhat of a hack to make it the same so that later our view is simpler. But I did this to show that this is one of the ways that you can set your statuses, and then this can expand if you want to come in here later and say do in progress or blocked or add something else. It's a lot easier to expand a list that's separated out like this as all caps. So it's technically called a constant, even though there are no constants in Python really. It's a variable. Human readable, we look at that and say, okay, that's constant. And it's stored down here. So it's one way of planning for larger projects. All right, now another good thing to do is to set a default.
Could I ask some?
Sure.
Okay, so the complete,
Mhm.
Each one of those complete, and to do is a tuple, right?
Yes.
And
Each one of these is a tuple.
They're contained within a list, which is called statuses, right?
Exactly. It is a list,
Okay.
a list of tuples called statuses. And then we're passing that as our value for our keyword argument choices. And then we're going to set a default, and default could be set on literally any field. You could put a default up here, default title, default whatever you like. It's a good idea for a drop down, so it defaults to something. I think that's probably the way to go. So I'm going to default to do because that's probably the logical thing for a to-do list. And also defaults are useful when if you add anything to this, like say we come back later and we want to add a assignee or something like that, and any tasks we have saved before don't have that particular field, the default is going to be required to put in on any field that didn't have that field already, any record that didn't have that field already. All right, so there we go. So we got our title, we got our due date, and we got our statuses. And that is all that we really need as far as fields go to define our task model as we define it in our project. The last thing we're going to do in this model before we wrap up here and save it is we're going to give it a method that will give us some information back that we can read when we're looking at our admin panel, which we're going to go over and look at here in a second. So when we do that, this is also, again, a very standard thing to do. We're going to define our method. So the same way we always have before, we're still inside of our class. So I'm indented over 4 spaces. I'm going to do DEF to define this. I'm going to do 2 underscores, str 2 underscores. This is defining a string method is what this is called. And it is going to, like all methods, start by taking self. That's all it's going to take as an argument. So all methods, all class methods refer to itself first. And this is simply going to return a formatted string. If you remember, we did formatted strings earlier in the course. It's just the letter F lowercase and then opening quotation marks. And then we put in curly brackets and we could put in different aspects of that thing. So we're going to put in self.title, the first set of curly brackets, because we'd like to see the title of things. And then let's say maybe we want to see the status. So self.status, close curly brackets. And this is exactly what we did with our classes when we did the cars and we returned the formatted string. This is basically the same thing. It's just going to show up in our admin panel and some other places, but mostly there. That's the most important place for it. So I just save that. And then the next step is a very important step that I forget constantly and is really annoying. We have to register this model with our admin panel so that we can then see it over there. So let's go over and do that. To do that, so we're going to get over to our up folder in the to-do directory. So the same place where our models.py is, in the same directory, just the admin.py is what we're looking for. So we're in the to-do directory still, my site to-do, admin.py is what we're going to open up. And this is automatically has this import admin here, and this says register your models here. So we're going to add two really simple lines of code to register our model. First, we've got to import the model that we made, and then we need to tell this admin site to register our model, basically. All right. So the first thing we got to do is just like any other import statement. We're going to do from, and we'll say dot, which is the directory that we're in, the to-do directory, right? It's the same thing that our admin.py is in. So dot models. We're going to import task. So we know it's singular because we're followed and we know it's uppercase because we follow the convention. When we define our class, we don't have to go double check. So we're importing our task model. And then under where it says register your models here, and we can do it anywhere, but we're going to do it here underneath our import statement. We just type admin lowercase dot site dot register, and then open parentheses, the name of the model you want to register, so task, and then close parentheses. And that's it. So I'm going to save that. Now we have made our task model. We have defined it. We've given it its fields. We have registered it, so it will show up in our admin panel. The last thing we need to do is a two-step process of making and running what's called migrations. So we're going to go back to our console to do that. I left the console open.
Hey,
So
can I?
Yep. Sure.
Okay. What exactly is the admin doing here?
So I'll show you real quick, and then I'll show you, let's see. Labs. Wait, Air Labs. There we go. Let's go to our site. Not about. All right. So on the admin panel, if you navigate to your home page and then go to admin, and this should be, if I remember my password, which I may not. Let's try. Nope, that might not be it. Oh, okay. So I'm gonna have to make another one. When we go into our admin panel, though, we're gonna go here in a second. I'm actually gonna create another one. So this is something to do. If you forget your admin login from day 6, this is what you can do to fix that, right? So we're gonna need to log into our admin panel, and I'm gonna show you what that is. So I need to get into this. So I'm gonna make another one. So I'm just gonna create another admin login. This is a real quick way to do this. So I'm in my same place where my manage.py is. I know that by tab completing. So I'm going to do Python 3 manage.py. I'm going to do create super user. Make this just a little smaller so we can see what's going on here. User, I'm going to do admin _2 because I'm pretty sure I haven't used that yet as my username. Do email address is come on now. Admin _2 at, it doesn't have to be a real email address. And now I'll give it generic password, and I'll do it again. Oh. All right, there we go. So now I have the admin2 super user made in there. I'm gonna refresh reload on the server the information. I'm going to go in here. I'm going to refresh this real quick. Oh, yeah, I am going to refresh that. Cool. So let's do admin 2 and our new password. All right. So this should have our users and groups. We got our tasks in there already. So this is where we are going to be able to see the things that are in our actual database. See, we have an error. So this doesn't exist yet because we haven't run the migration. But when we come in here, this is to refresh your memory where we did when we made users. Here was our first admin user. If I want to make any changes to this, let me again zoom out so it's not so jumbled up in here. So here's where we get into our admin actual thing. This is just a table. So this users thing is a table. Here's our task table that we sort of define so it exists. What we did when we registered it on this admin thing is to tell it to show up here. So here it is. That makes sense?
Okay, yeah.
This is the admin panel. This is admin.py that registered our task and said, hey, there's a task thing. And so you add tasks with an S over here.
So you're basically just kind of keeping track of it here, right?
I'm going to show you what it does. One second.
Okay.
Let's finish this step, and then I'm going to show you exactly what that's doing. So I had to go through those steps again and create the super user anyway to get to this. So I'm glad you asked. But let's run this migration, and then we'll go there and we'll show you exactly what's going on with it. So it's the last step that we've got to do for this part, and then we will do the CRUD operations with the last like 30 minutes of the class. So the first thing we got to do is we have to make the migration. So we've created our model. We've defined our model. We've registered it with the admin panel so we can see it. We know we can see it there, but we broke when we clicked on it, right? We got an error. So we have to migrate into it. So the way we do that is Python 3. So we're in our my site directory, same place as our manage.py. So we start writing manage.py, use tab complete to make sure we're there. And then we do make migrations, all one word, all lowercase. And this command is going to go through the models.py file and see what has been changed. And it's important that in your settings, in installed apps, you have to do properly set in there. And if you don't, and it comes back and you did every step up to now, and this doesn't say, it says there's no migrations to make, and it doesn't say something migrations for to do 000 initial.py in the to do / migrations directory, make sure that you have it written down in installed apps. All right, so this says exactly what happened. It says create model task. All right, so we made that migration. Now we need to actually run what's called the migration to migrate it, to put it into the database. So this is set it up. This has created this file. We go look at this file. We will go look at this file in a second, but let's migrate the database first. So we do Python 3, manage.py, once again, same thing that we've done several times. And then we're just going to do migrate. When we hit enter, what this is going to do is going to take everything that's written in this migration file that was made by the make migration command, and it's going to migrate it into the databases. So this migrate command is where the boiling down what we wrote in a class into SQL is like the last step of that. One step of that is the make migrate to put it in this initial.py migration file. The last step to make it into SQL and put it into our database is this. All right, so I'm going to hit migrate. I want to hit enter, barring anything unforeseen. So set apply all, and there's the other ones that are generally in there, the admin, auth, and basically it's just going to take any changes to any of these tables. There weren't changes to any of them except this one. So it said applying, and then it says our status. It says it's all right. So that should be.
What exactly is migrating here?
This is the class that we wrote in the models.py is being put into this the initial.py file. Let's have a look at that file actually. So now if we go into to-do, there's a migrations directory underneath our to-do directory. If we go into migrations, there is a 0001 underscore initial.py. That's always going to be the first migration that you run. And if you open this up, you'll see exactly what's in there. And don't edit this file, but you can look at it. So it's got a class that's a migration, and it does the same thing we've seen with inheritance, and does some other stuff, dependencies, and all these things. And then if you scroll down, you can see the model that we made, right? So here's title. You see it broke it down into tuples. but it's the same information that we wrote. So what it did was it broke this down into the format that it needed to when we wrote make migrations into this class. And what this class is going to do when we do migrate is it's going to convert this into SQL in some way and it's going to run a SQL command that says create this table with these fields. Does that make sense?
Okay.
So that's what that migration is. That's what migrations are doing. So now that we've got that, I'm going to reload good measure on the server. I'm going to hop over and refresh our admin panel on the browser side. I'm going to go over on tasks. And when I click on tasks this time, it didn't break. So now it says that we have 0 tasks, but now we have this button up here that says add tasks. So what we could do now that we've defined our model, we've made it, now through the admin panel, we can do those CRUD operations that I told you about. We can create this add task that's creating, right? So now we have the fields that we defined. Here's title, new task. Here's a due date where we can put in dates. It says I'm 7 hours behind server time. That's good to know. It's got a date picker already built in. I didn't have to do any of this coding at all to pick a date picker. So here we are. And here's our default status with a drop down already built in, which is what we set up in the back end. So now we can save this. We can add more, right? Now we can read it. So here's the string that we passed to that method. So there's the name of the task that we put. Zoom in if we need to. Here's the name of the task that we put, the new task, comma, and then the status of it to do. Right? So that's creating tasks. We could update this. We could change it to, do something else. Save it. And now there's the task. It's in there. We can also delete it up here. It says, delete selected tasks. We could delete that and make new ones. So that is a way to do CRUD operations. Now that we've defined our model, we've made the database table, we can interact with it. We can save information. We can make our tasks. All right, so course is done a week early. Everybody go home. No, what we're going to do from here is we have to make what we call the interface for most users. This is what a super user, we created a super user. We're logged in as a super user. This is a super user or an admin user's access. We don't typically give this to users on the front end, right? You're not typically going to give this to everybody in an organization. What we're going to do is we're going to build a way to interact with this to-do list on our website so that there's a barrier between what the end user sees and this interface right here. We're going to largely replicate a lot of these same kind of things. It's going to look a little different. We're not going to make it look as slick as this, but this is generally what we're doing. We're going to be creating this for our end users on top of the same model, but this is a way to interact with it. So is that clear for everybody? Anybody have any questions about that and where we are up to there?
All this is baked into the task.
Yes.
Okay.
So this is all in the admin panel. This is all what's built in. We can go and view our site from here if we wanted to, and it'll take us back to the page. And it looks no different yet. We haven't done anything on the front end at all. But this is a way to add tasks now on our task list.
Okay.
Or to-do list. All right, cool. So now let's pivot into writing our first CRUD operation. So we're going to start actually not with create. So the order, if we were going in order, would be create, read, update, and delete. That makes a better acronym than RCUD or something like that. But we usually start with read because creating and updating, first of all, they're very related to each other, but it's also a little more involved. You have to make forms and things like that. Whereas reading, you generally just have to do some sort of SQL statement similar to what we saw in the example SQL statement of just going and grabbing something and looking at it. And then you have to give users on the front end that display. You have to display it out on your page someplace. So we're going to go through that flow of building it. The process here is going to be very similar to what it is every time you build anything. We've already done it a couple of times where we write a view in our views.py. We map that view to a URL in the urls.py. Then we make a template if we don't have one already in our templates file somewhere, either project level or app level, depending on what we need. We're going to do app level today. And then we need to do some sort of navigation from the existing pages we have, probably project level pages, to our new views that we made, our templates, or whatever it is we need to do. So some sort of navigation. Those are sort of the 4 pieces that we're always going to go through when we add functionality to our web applications. Create a view to interact with the database, map that database interaction through a URL to an actual page site location, like this up here is mapped, the higher, my username, Python anywhere, /admin /to do /task. We're going to be doing that when you map to a URL. And then you need to make a template. That's what this whole page here is, a template somewhere where somebody defined this thing to say Django admin and all the colors that are on here, front end style. And then that last thing is navigating to this. So some way to get to these new pages that we make. So those are the 4 steps that we're going to go through. All right. So we're going to leave this. Actually, I'm just going to close this since we have this site open. And as a reminder, this is where we ended up last time. We have our, not amazing looking site, but there's something going on here. We did some colors and some imported things. We have our homepage, which is where we are now. We have some basic navigation. If you've got to hook up the JavaScript, gives a little warning when we go to our about page, but the navigation works like it did. So let's get going on making the updates that we need to make, starting with writing our views. So we're going to go to our views.py. I'm just going to go there from here. So to do, we're going to go into our views.py file. So my site, to do, views.py. This is where we have our index and our about views already defined. And we're going to continue writing functional views for all of our CRUD operations to begin with. We're going to do all 4 of the CRUD operations with functions. And then if we got time, as we got time on next Tuesday, hopefully we can refactor quickly into classes and use the inheritance in classes. But you can do functional or class views. We're going to start with functional views. So we have those locked in. We have those patterns established. And then we'll refactor into classes as we have time towards the end of the class. All right, so let's get our view for the tasks. We're going to define another view, another function like we had before, DEF. We're going to call this view underscore tasks. Now, arguably, we could have called this like to do index or something. That is kind of a common way to do it. But I want to keep in our mind that this is how we are viewing something out of the database, right? This is the read operation that we're going to go with. Right, so it's going to take in similar like it has before because we're still using HTTP. It's going to come in with a request. Then we're going to enter our definition of the function itself. So the first thing that we're going to do is we're going to define an object. I'm going to give a couple more spaces here just so we have move this up on the screen a little bit. So we're going to define this variable called tasks, and it's going to hold all of the tasks in our database that we want, right? So this is something that if you have multiple users, you could do some filtering by user. We're going to do a very simple, grab everything that's in there and just store it in this tasks object, and we're going to send it forward to the website to be viewed, to see all the tasks that are in there. So if you think of our SQL statement where it had from which, or select what from which table where it meets this criteria, we're going to include those similar objects or parts in here, slightly different order. So we're going to start with the table name, so task, all caps. So we're going to say, this is like the from, right? And then we're going to say what we want from it, say objects, and then what filter criteria we have. And we're just going to take all of them. So the name of the table, capital task, dot objects, dot all, open and close parentheses. So this is going to get all the objects out of the task table, and it's going to store them in the variable called tasks. Now we're going to define another variable that's called context, and this is the information that comes with an HTTP request. It's other stuff that you want to go along with the request. So anything that you want to be available in the front end in our template to show, display, do anything with, we're going to include it in our context. So we will do this as a dictionary, open and closing curly brackets. I'm just open and close those right away. And then we're going to do a key value pair with tasks as our key, as a string. We could have named that anything we like, but we're going to keep it somewhat reminiscent of this so we know what we're talking about. And then we're going to actually pass that tasks variable that we defined above as our value. And the trailing comma, in case we want to add more things to context later so we don't forget the comma. But so what we've done is we've defined our tasks variable. We've pulled all of our task objects out of the task database table. This boils down to SQL eventually. This is where the SQL is kind of happening. And then we've sent that into this context key value pair as a thing called tasks. We have sent that in there. So now the last thing we have to do to make this view function complete is return something. So we got to return like we have before using renders, because we're going to render it out on the screen. So we're going to take the request, we're sending the request along because it's got some info that we need, headers and whatnot. And we're going to, just like we have before, give it the template that we want it to render. So this is a template, again, we have not made yet. We will make shortly, but it is going to live in to-do slash, and we're going to call it view-tasks.html. And then the last thing we're going to pass to this render is the context object that we made. Now, this is our fully formed view. So we're going to save this. And this is telling me, we have a little error, undefined name task. So I forgot to import our tasks. We got to do that. Get that every time. I meant not to forget that this time, and I did. So same way that we did before, we're going to import models from .models, because we're in the same directory. Our views.py is in our to-do directory, just like our models.py. So it's from .models import, and then we explicitly say the task name that we want. Now we could, as a side note, we could put an asterisk here and just import all the models, but there's a risk that you're going to have conflicts. So it's best to explicitly write out the name of the things you want to import. All right, so now when I save it, that error goes away, that warning goes away, and we should be good to go. All right, so that's our view. That's the first step of 4. Second step is what? Anybody? Views, then. I'm almost there.
Let me look.
Forms,
Nope, almost.
URLs. Okay.
Map a URL. Yep. So view is almost in like reverse alphabetical order, right? So you start the views and then you map a URL. So we wrote our view. Now we're going to map that view into a URL. So if you recall, the view returns a render. The URL maps like where to render that. So this is where we're going. All right. Now we're going to follow the same pattern. It's going to be very, very simple from here. We're just going to copy this path from up here. You could write it from scratch if you like, but it's just path again. And then we're just going to change the about pieces to something else. So because this is really the sort of landing page for our to-do list as it is, I'm just going to call it, to-do / because that's what's going to read up in the URL when it was a to-do list. We could call it to-do list. You call it whatever you like. Doesn't really matter. This is what the URL is going to read up here at the top. And then we'll give it, and we call the view that we defined earlier. So if you remember, that was view tasks, right? And then the name that we want to actually give it. So view tasks. So following the same patterns that we've done before, we're going to define which actual URL we want this to go to, which view we want to use out of our views that we've already imported, and then give us some kind of name that we can reference later. We can reference in our links, we can reference in our A tags, all those sorts of things. All right, so now that we've got this all defined, we are going to go make a template. So this is going to be a bit more HTML and kind of front-endy sort of things, but this is really the kind of full stack development that we're going to do. So we did front end last week. We're going to practice a little bit of it now when we make this template. And we're going to show a few more techniques on how to grab these things now that we've done that context object and we have something from our database. We're going to show how to interact with those objects on the front end and grab each one and do different things and display different parts of it on the front end. So to do that, we're going to go over and build our template. The first step in that is we're going to have to make the directory of those templates are going to be. If we go back to our console, and I'm going to do it in my console because I prefer doing it in here. It's just faster for me that way. You can do it in the GUI. It's a little bit more user-friendly, I guess, if you like that. But just to refresh everybody's memory, I'm going to run this tree command one more time and show sort of where we are directory-wise. Our to-do directory does not have any templates of its own, right? There's no template subdirectory yet, so we're going to make one because we're going to have templates that are specific to this application. Our project level templates are still going to be the about, base, index, and all that sort of thing. Now, when we make the templates directory inside of this, it's going to be called templates. We're going to then have to make another directory inside of it called to do. So it's going to look kind of redundant. It's going to say to do templates to do. The reason we do that is because Django looks for everything called templates, and it grabs all that and kind of combines it, similar to what it did with the static. Similarly, somewhat like that, so that it looks sort of in one place. So it basically looks in every subdirectory for its templates. And this way, to make sure that you don't have any conflicts, we add the application name underneath the templates within its own directory. So that's what we're going to do. We're going to make this templates directory inside of to do, and then a templates to do directory, like all the way inside of it. So let's do that with our mkdir command. We're going to do very simply to do and tab completes to show that we have that already. And then we'll make templates, and we can make more than one directory at a time with this command. So I'm going to go ahead and make my second sub directory templates to do. So there's the redundancy to do templates to do is the full directory. And I'm going to do 2 ampersands, another command, because we're just going to go ahead and make the file while we're here and knock out, I guess, two birds with one stone, or however many birds, I guess, you like with however many stones. So using the touch command, we touch space, and then we're going to enter that full end directory, the to do slash templates. I'm going to move the zoom stuff so you can see what I'm writing. Templates slash to do, and then our file name, which as we already defined is view dash tasks.html. If you recall, that's what we define in our view, that the template name that we're going to be looking for when we run our view. So what we're doing with this command is making the template directory inside of the to-do directory, a subdirectory to do, so that it doesn't conflict with other templates in the project, and then our view tasks HTML template. Cool. So now that I've done that, back in our more user-friendly GUI, when we go into do, we should see our templates directory, our to-do subdirectory, and then our view task HTML. And it's totally blank. Excellent. So this is where we need to be. And we're going to do some work here and make ourselves a slick little table to look at all these to-do lists that we're going to have. So it's pretty basic HTML we're going to use. We're going to leverage Bootstrap a little bit more like we did before. We're going to do the same things that we've done with the template language before. We use the same base template, so we have the same navigation at the top and all those things consistently throughout our site. So the way we do that is we start by opening up some Django tags. I'm going to close them as well, so I don't forget to close them. And we're going to use our extends, E-X-T-E-N-D-S, all lowercase. And then we're going to say what to extend, what template exactly to extend. So we pass base.html as a string. And that's going to grab all the parts from our base.html. And now we need to tell it what we want to put in there. So we do a block element. That's a reserved word. And we named our block content. And again, we did that somewhat by convention, so we don't have to now go back and look. We just know that it's named content because that's the main content that we put in there. And we close off our end block. All right, now this is how you start pretty much any new template that you do in Django. So whatever you write in the middle here is going to be injected into that view or into the URL that you've defined in the views and the steps up to now, right? So let's quickly throw in some fairly simple HTML. So we got something to display on the screen. So we'll start off with a header. We'll just say tasks. So it's just an H3 element. And then we're going to make we're going to use the div element and make it a table that's responsive so that it looks a little bit interesting. So we'll say table dash responsive. And since we're doing mobile first, I'm going to make it, small. So on small screens, it's good and responsive for us. Now inside this division, we're going to make a table. We're going to use just the table tag. And we are going to give it class table dash, both table and table dash hover. So that's going to do a couple of things. This table class, these are built into Bootstrap. This table class is going to give it the rows and the columns and stuff and kind of even it out. The table dash hover is going to make it, when we hover over it with a mouse, it kind of highlights the row that we're looking at, right? So it's going to give it something a little interesting to look at. All right, cool. So now we've got inside our table. The way we're going to do this is we're going to put table row at the top with the headers inside of it. And then underneath that, we're going to use Django to call each of the elements out of our context object and put any tasks that exist up into those columns underneath and make new rows for it. So let's start off by a TR is a table row, and then TH is table header. And we just put simple text in here so we know we're gonna have a title. I'm gonna copy this TH tag and paste it a couple of times because we're gonna have our due date, right? So we got due date and our status, right? So those are the three things that we have as the headers in our table. So the next thing we're going to do is we're going to be making another row for each to-do item that's in our task table, right? So we're going to have to use Django in here to loop through and grab each one of those and do something with it. So we're going to use Django tags, like we have the front end Django tags, the open curly brackets, parentheses, close curly bracket, or sorry, %. And we're going to use similar syntax to what we've seen in Python to do a for loop. So for, and we're going to do task. This is an arbitrary name of a variable in tasks. Now, tasks is not an arbitrary name. That's what we defined in our context in the view. Remember, we sent the task. This is all the things that we pulled out of the database is this tasks object. So what we're saying here is say for each of those, we're going to tell it to do something. Now, in Django, we have to end the for loop. So I do this first because I will always forget to end my for loop. So in Django, end your for loops. And then inside the for loop is where we're going to tell it what HTML to make for each one of these tasks. So each one of these tasks is going to get its own row, just like the header we had above. We're going to use the TR tag. And then instead of TH for headers, we're going to use TD for table data. And then we're going to fill in the data that we actually want to see. So this is the other part of the Django's front end that's very important to know. We've been using this curly braces and %. And now when we want to grab a specific thing out of the database and get information out of it, like the title, the status, and the due date, like we're about to show right here, we need to use double curly brackets, open and closing, double curly brackets. So I'm going to open and close those to get started so I don't forget them. I don't forget to close them. Then we're just going to call our variable name up here. So remember, it's task. So each task in the tasks object that we sent in our context, the first thing we want to get is the title, right? Matching our header up here. So task dot title, just like we would with any other object call in Python, like we did before. When we call things from classes and we want to get the attributes from a class, we call it exactly the same way. So I'm just going to, again, copy and paste these table data elements and adjust which attribute is called to status or due date and status respectively. All right, so the last piece that I want to do here before we move on, this will work for the most part. The only problem that we have here is that if there are no tasks in the database, this is just going to break. So we're not handling that scenario of no tasks at all, right? So what we want to do is we could just have a check using Django's template tags again with the regular ones with the curly brackets and the %. And we're going to open one up here and we're going to use a if statement, just like we did in Python, and just check some logic real quick. So we're going to say if tasks. This is just saying if there are tasks in tasks. If task is empty, then it will skip this. So this is the if part right here in the case of a task being in tasks. Now, if there is not, I'm actually going to go down here past the table, past the end table right before our end block, still in the div. So it's a little bit more responsive in there. We're going to add our end if, so we don't forget, because Django always wants the ends. Got to remember to end your ifs, remember end your fors, the same things, the %, curly brackets. And we're going to put our other condition here, our else condition, just like we do with a regular if statement in Python. I want to do a paragraph that says no tasks found. So what this is doing is just handling the scenario in which we don't have any tasks in our database. We did make one and we saved it, but again, if you didn't, this if statement will check to see if there are any tasks in there. If there are not, it'll skip down to this else statement and just print out a paragraph that says no tasks found. If there are, it will create a row for that task and the table and all that. All right, so let's save this and do one last step before we try it all out and make sure it worked, which is navigation to this new view. So we have this template that we made. We got this view. Now we got to navigate to it. So we're going to go to our top level template and add something to our base.html that will allow us to navigate here. So we remember our navigation bar is on our base.html. So that's where we're going to add an A tag that's going to point to this new template. So to do that, we're just going to go to my site up here at the top, straight there, my site, templates, base.html. Call that partway down. Here's our navigation bar with our about and our index or our home buttons to get us home. This is where we added our delete thing. We can take that off if you want to. I know we went through a hassle getting it started, but we can take that off for now because we're going to save that delete confirmation for the tasks now that we have them. We don't need it on our about page anymore. And I'm just going to copy this A tag again. We're just going to add another A tag down at the bottom. And we're going to update the URL to view tasks. And we'll change this to to-do list. All right, that's it. So we've just added our navigation to our nav bar in the template. We're going to save this in our base.html. We created a new template in the to-do list. We wrote our view. We mapped it to our URL. Let's reload our source code on the server. And let's see if I managed to break everything. All right, so there it didn't look like it broke yet. So we added our new link at the bottom of the list in the nav bar here, so to-do list. And if I navigate to it, we can now see here is the header of the task I made, and here's the table. As you can see, it's laid out fairly decently in the middle of the page, and we have the task that we made on our admin panel side that has the due date that we gave it and the status that we gave it. Now we can't do anything with this. We can't interact with it in any way yet because we haven't made the other operations, the read, update, with the update, delete, and create. So right now all we can do is read, but that is the first of our CRUD operations.
This is just C, right?
This is just seeing it. This is just this is the R in CRUD. This is the read. So we are reading. All we're doing is reading what's in the database right now. So when we navigate to our URL that we defined, when we click on this button from, let's say we're at home, right? We click on this to-do list button right here.
Okay.
When I let go of this button, it's going to send that query that we defined in our view that said tasks capital dot objects dot all open parentheses close parentheses. That's going to go to our MySQL database. It's going to be boiled down into SQL. It's going to pull all the objects out with that select from where statement. It's going to give that back to Django, and it's going to put it out on our page at the URL we defined in the template that we gave it when I let go of this button.
Okay.
And so now that's all that happened. And this is the display that we told it to display. So we said for each item that's in there, give us its title, its due date, and its status. So all we're doing is reading. So we read what's in the database and we're looking at it now. Make sense?
Okay. Yeah.
All right. So that is the checkpoint for today. This is where I want everyone to be able to get to before we crack on next time with the other operations that we're going to do. We're going to start with create, and then we'll move to update. Those are very similar, but again, there's slight differences. So create, you're starting with nothing. You use a form. You submit some information. With update, you have to get something first, change it, and put it back. So they'll follow somewhat similar patterns as each other, but it'll be a little bit more complex than what we did with just the read. But it'll be in similar patterns. We're going to write a view, map the URL, make a template if it doesn't exist, and then map our navigation as necessary. But it'll probably be on here, like all the further buttons. We're going to add an add button, a delete button, and some way to update things by clicking on them. any questions before we wrap up? We've got about 5 minutes before the end of time. Not all time, just class time. So relax.
Okay.
Any questions? Yeah, what's up, Cody? What you
I
got?
got a question. So in terms of application, right? Real world application, the being that this is like the front end, like a task list for somebody, right? This would normally be walled off, right? So
Yeah.
I guess where I'm coming at with regards to security wise, like RBAC,
Yep.
would that basically be listed under like a group or something that isn't really public facing but is walled off by like a UAP or something?
That's a really good question. So there's a number of ways you can do that. And one way that's really common, you can use permissions and groups and things like that. But in your views, you can define things like requiring people to be logged in to see some of these views. So like there are built-in requirements to do that. And then there are ways to say filter just a particular user. Like, so the user that was in the request will have a user if it's logged in. So like you set this to be required to log in. And then you say the request user just show like tasks that match that user. So it'll just show their tasks, right? So that's one way of kind of separating the views out and only showing particular users what's theirs. And then on top of that, yeah, you can use built-in stuff in Django like groups and set up little permission schemes and then use those permissions inside of your templates to say like, if in their permissions they have whatever permission you defined, then show them this on the template and then they can click around and do those things, right? So that's another kind of built-in way to control the access and what's seen or accessible here. Does that answer your question?
Yes, it does.
Cool.
Thank you.
Yeah, no worries. No worries. Good question. Any other questions?
Would try and accept have been valid options instead of the if else?
Good question. You mean in the
Yeah,
the
where you
front
just
end?
open up and say, here, try this. And if that fails, it catches the exception and says, sorry, there are no tasks.
I get what you're saying. So
I'm just curious.
yeah, you're talking about just so that we're really clear.
It's just because it's simpler without all the tagging and everything else, right? You just throw up
you're talking
try
about
colon, and then down at the
in
underneath your code, you do accept, and then say,
you're talking about here in the
yeah,
template where we did the
yeah.
if to look for tasks.
So basically, replace that with try colon, and then down below, rather than doing the else.
I don't
and
think
if.
so. I don't think so because I don't think so. This, even though it looks like Python, it's not really. It's actually Django's template language, quote unquote. I'm not sure if they have a try statement in that language, right? So it looks just like Python, but it's not exactly.
Sure, because really this is an HTML based document, not necessarily. Yeah. Okay.
Right. So this right here is like kind of doing what Python's if does, but that's a good question. I don't know if there's an equivalent try block. I've never even considered because I don't really use try blocks that often anyway. But
yeah, it's just that a lot of the code examples when I'm looking up trying to figure out how to do something, I see this try except a lot. So I've actually adopted several uses of it, and I'm just
that's a good question though. I mean, I've never thought about it in
cleaner,
front
but
end.
it's
I've never thought about it in a front end thing, but I wouldn't assume that all things that are in Python are available in Django's front end template language.
Yeah. And I guess now that I think about it, I've been using it in things like the views and the forms, not in the actual HTML documents.
Exactly.
So, yeah,
views and forms are going to be written in pretty much pure Python. So that's where you definitely could be using try and accept instead of the if logic. Good question though. Yeah. Any other questions about any of the things we covered today? I know it was a lot.
I'll go through the documentation. I'll make it happen.
Yeah. Keep practicing. That is the key. And the documentation, again, has got all the steps. So don't be afraid to throw stuff out, start over. This one's a little tricky to throw out and start over because once you do a database migration, you have to like throw out everything and start over, or else you might run into conflicts and stuff like that. But that is totally possible. Like this migrations folder, just like we've done before, you can get rid of the migration files, you can get rid of the directory itself and run migrations over again. So be aware though, that if you do that, if you just change out these things here, it's not changing your database. The database is a yet another thing that is in the top level project right here,
Okay.
which we can't even open because they don't want us in there messing around with it. But so you can go in and you can do all kinds of stuff in the models, and you can manipulate the migrations files, and there are reasons to do that, reasons to check it, but again, be aware that you're interacting with the database at some point, and that might be your sticking point. So if you're trying to go through this again and again, you may have to back up to before today and throw everything out just to get it fully clean, just so you're aware.
Okay.
Now, is there a console way you can interact with that database?
With this database,
Because there should be a way for you to enter the Python console
yeah,
and
yeah,
do like
there's a way you could mess around.
tables to get the tables out of it.
You could do basically the same kind of writing views and doing the same ways you would in here, just interacting directly in the console, and do the same like calling that we did where we did the tasks and stuff like that. You could do that directly, yeah. And that's the same kind of syntax we used in the views to interact with the database, basically, that you would do in a Python console. It's a good question too, yeah, in an interactive shell. You could do that. And sometimes that's helpful when you want to, like, you've made a model and you want to kind of test it out to make sure it behaves the way you think it will, or that you draw stuff out of it the way you think you can using a view before you actually write the full view and map the URL and test it all that way. You can kind of mess around with it in the shell and pull stuff out of the database and look at it, play around with it, and then go and actually write your view based on that. So that's a good way to do it. Yeah.
Yeah, I guess kind of what I'm thinking is I've been dealing with a lot of database, but one of the things it doesn't show you, and you can go to the admin page or wherever, and it doesn't show you the index number, even though there is an index number.
Yeah.
And I need to know, like, I want to check something for its index number because I'm looking at the debug output on my page blew up and it's giving me a problem.
Yeah,
but that was based on a URL that went to a something/ID, and now I don't know what the ID is. Yeah. So I want to go look at the database and find the ID, but it display it to you.
Yeah, like the interactive shell. The interactive shell gets you there. And again, that's like the best way to do that is to go in there and try pulling stuff out and see what you can get out of it. Because you can definitely retrieve IDs. It's usually actually called ID. So like just try calling the thing .id and see what it gives you. But nice. All right. So yeah, everybody definitely practice these things, roll through the documentation. Let me know if you have questions. We're gonna keep going with this on Thursday. And yeah, that's it for today. So thanks for your time and attention. We'll see you all Thursday.
Okay. Thank you. See you.
See you later.
Thanks, Steph.
Yep. Thanks a lot.